Shear force and bending moment. Engineering topics. What is shear force and its effects? In solid mechanics, shearing forces are unaligned forces acting on one part of a body in a specific direction, and another part of the body in the opposite direction. When the forces are collinear aligned with each other, they are called tension forces or compression forces. Shear force can also be defined in terms of planes. If a plane is passed through a body, a force acting along this plane is called a shear force or shearing force. Also, shear force is a force that acts along a surface, rather than perpendicular to it, and can cause a material to deform or fail by sliding or shearing. Understanding shear force is crucial in engineering disciplines like civil, mechanical, and aerospace engineering, where the stability and integrity of structures are paramount. Shear force leads to shear stress, which is the internal stress within a material caused by the shear force. Shear strength is the ability of a material to resist failure under shear forces. A shear force diagram visually represents the variation of shear force along the length of a beam or other structural element. Shear center. In structural mechanics, the shear center is a point where a load can be applied without inducing torsion. Shearing in soil mechanics. In soil mechanics, shearing can cause volumetric strain, leading to dilation, increase in volume, or compaction, decrease in volume. In some materials, shearing can localize into narrow bands called shear bands, where all the sliding occur. What is bending moment and bending moment diagram? A bending moment is the internal resistance a structural element, like a beam, exhibits when an external force or moment causes it to bend, typically measured in force multiplied by distance. A bending moment is the reaction induced in a structural element when an external force or moment is applied to the element, causing the element to bend. The most common or simplest structural element subjected to bending moments is the beam. The diagram shows a beam which is simply supported at both ends. The ends can only react to the shear loads. Understanding and calculating bending moments is crucial for engineers to design safe and efficient structures that can withstand applied loads without excessive deformation or failure. Beams, a common structural element subjected to bending moments, where the bending effect is most noticeable. Columns can also experience bending moments, especially when subjected to off-center loads. In a rigid body or in an unconstrained deformable body, the application of a moment of force causes a pure rotation. But if a deformable body is constrained, it develops internal forces in response to the external force so that equilibrium is maintained. An example is shown in the figure below. These internal forces will cause local deformations in the body. For equilibrium, the sum of the internal force vectors is equal to the negative of the sum of the applied external forces, and the sum of the moment vectors created by the internal forces is equal to the negative of the moment of the external force.